Laboratory for the cardiovascular system. 1. Learning objectives for the heart. Be able to recognize and describe the endocardium, myocardium, and epicardium, as well as cardiac muscle cells and Purkinje fibers. 2. Learning objectives for blood vessels. Be able to recognize and describe the three coats, tunica intima, tunica media, and tunica adventitia, and their subcomponents in the following classes of blood vessel: the elastic or conducting arteries, muscular or distributing arteries, small arteries, arterioles, capillaries, venules, small veins, medium-sized veins, and large veins. Relate these structural differences to the function and classification of each vessel. The field of view is a portion of heart wall stained with an iron hematoxylin and eosin stain. What this scanning illustration demonstrates is a region of the endocardium. This thin connective tissue layer is being traced by the pointer, and at increased magnification it can be demonstrated that this surface is indeed covered by or lined by an endothelium. So this layer that extends from where the tip of the pointer is now illustrating to the lumen is indeed the endocardium. The remainder of this huge muscle wall, as indicated by the pointer, is a portion of the myocardium, which of course consists of cardiac muscle. Now, if one courses slowly through the muscle wall, note that the arrangement of the cardiac muscle cells in various bundles or tracts or trains of cells cut at a variety of different directions as these cardiac muscle cells and their associations form sort of an interwoven pattern throughout the muscle or myocardial wall. Here they're cut somewhat crossways, here they're cut longitudinally, here they're more obliquely in section. And this is the type of pattern one sees as one goes through the myocardium. We're still in the myocardium. You can see it is also associated with larger vessels that are supplying it, obviously. And finally we get to the exterior wall, and this is the appearance of the epicardium, that layer that's on the exterior surface of the heart wall. It consists mainly of fat and a loose type of connective tissue. It too will be surfaced by a simple squamous type of epithelium, but in this particular case it'll be the mesothelium that is lining the pericardial sac. So you have a visceral and a parietal layer of this pericardium. The epicardium is that visceral layer of the pericardium. Consists mainly of, like as I mentioned before, of fat and connective tissue, and it is this thick fatty layer that will house the various vessels, the named vessels that one will dissect out in the gross lab. So when the students are digging out those vessels, those named vessels, and tracing them on the exterior of the heart wall, which indeed what you are actually digging in is this epicardial layer. In this particular case, it's fairly thin. So let's retreat now, again noticing the interwoven pattern, the arrangement of the cardiac muscle cells through the myocardium. You can see the various directions this interwoven muscular pattern takes. And then beginning with the endocardium, examine it at an increased magnification. This is a demonstration of the endocardium seen at a slight increase in magnification. The endothelial lining is shown at the tip of the arrow, this medium power objective. So the epicardium, or endocardium, it extends from where the tip of the arrow is now pointing to its association with the underlying cardiac musculature of the myocardium. So this layer from here to about here, here to here, here to here, is typical endocardium. Now, as one courses through these particular regions, in the endocardium, one will oftentimes find bundles of the conducting portion of the cardiac system, and this is a small bundle of Purkinje cells. These large modified cardiac muscle cells specialized not for contraction, but for the conduction of impulses and coordinating the activities of the myocardium of the heart. So this again is endocardium. The endothelial lining can be seen at the tip of the pointer. This residual spotty type of material are erythrocytes that have been stained black with this particular stain. One can see it's quite common to find within the endocardium adipose cells, or these white fat cells. This is typical myocardial or cardiac muscle cells of the myocardium here. These are the Purkinje cells. There's 1, 2, 3, 4, 5, perhaps 6 of these very, very large conducting cells. Even though the details can't be made out very well on this particular preparation, because that's not what it was developed for, if you look at a cross-section of the cardiac muscle cells of the normal myocardium, this is a cross-sectional profile, this is one here, this is one here. Compare these cross-sectional profiles with an individual cross-sectional profile of one of the Purkinje cells, and one can see the tremendous difference in size. If we take this one, for example, at the tip of the arrow, compare it with the Purkinje cell cross-section, you can see the Purkinje cells are several times as large as the normal cardiac muscle cell. Having made that type of an observation, beginning on the interior surface with the endocardium, which is this layer here, by the way, again go through the myocardium at increased magnification, looking at the arrangement of the cardiac muscle cells. Again, realizing that they're cut in various planes, that it's an extremely vascular type of tissue, with each cardiac muscle cell having vasculature on either side. And one gets an appreciation going through the entire muscle wall of this interwoven nature of the cardiac muscle cells. A little bundle of Purkinje cells down into the interior. Usually you don't find them this far down or into the interior of the muscle wall, and so we're getting this interwoven pattern of cardiac muscle cells as one courses through, and finally ending up this thick fatty layer on the external surface, which indicates that the epicardium is now being visualized. And if one examines this particular surface, one can make out the nuclei scattered along. This is a mesothelial lining on the exterior surface of the heart. So the epicardium is, in fact, the visceral layer of the pericardium. So a thick, fatty layer on the outside, as one would anticipate. Having seen this, go to some routine types of preparations, re-examine the cardiac muscle cells, in particular re-examine the branching nature of these fibers, recall that it is a form of striated muscle, and be sure to identify the intercalated discs that unite these cells end to end and are important in communication, that is, transmitting the impulse from one cell to the other. Once again, this is a special preparation of cardiac muscle, simply used to demonstrate the banded pattern, the striations, as one can see at the edge of the arrow on this particular muscle type. Review the elements of cardiac muscle, that is, namely, it has a centrally positioned nucleus. It does have myofibrils that show this banded appearance, so one can see the A and I bands quite readily on this particular preparation. Note that this particular cell or fiber is branching. An intercalated disc is located at this location. Another is shown here. If one continues down this particular cardiac muscle cell, one can appreciate this particular one is binucleate, a rather unusual occurrence, the second nucleus appearing here, and then finally the intercalated disc where it joins another cardiac muscle cell located at the end of the pointer. Another intercalated disc from a branching fiber on this particular side of the field is shown here. These intense, dense nuclei, such as indicated by the pointer, are those of endothelial cells. Please do recall that this is an extraordinarily vascular type of tissue, the myocardium, and then either side of these cardiac muscle cells is associated with a capillary. Having demonstrated these particular features on this special preparation, now let's demonstrate the similar ones, see if these same things can be observed on a relatively routine preparation. Typical cardiac muscle cells using a routine or hematoxin and eosin preparation. This particular cardiac muscle cell extends from where the tip of the pointer now indicates, and you know that's the end of the cell because this is an intercalated disc, to about this level where another intercalated disc crosses the field. One can make out barely the myofibrils and the striated or banded appearance of the cell as well in this particular preparation. Once again, the gaps in these dense staining nuclei are endothelial cells as capillaries surround these individual muscle cells. If one courses along, you can see out the myofibrils quite well filling the interior of the cardiac myocytes or cardiac muscle cells. And again, intercalated discs, even though we're not seeing the cell cut perfectly throughout its entire length. An additional longitudinal section through cardiac muscle cells just to illustrate the red cells passing between individual cardiac muscle cells, and hopefully driving home the point that these nuclei, the long, thin, darker staining ones, are all endothelial cell nuclei. The cardiac myocyte nuclei are much larger and more euchromatic than the endothelial cell lining. So this is a blood vessel running here with the erythrocytes within it. Another blood vessel is coursing here. Another one courses here. We focus up and down through it. Another one is coursing here. Another one here, and so on and so forth. So literally every cardiac myocyte in life is enveloped and surrounded by capillaries. Having reviewed the morphological features of a longitudinal section of cardiac muscle, one should also briefly review the characteristics of cross-sectional profiles of this particular muscle type. The entire field illustrates cross-sections of the cardiac myocyte or muscle cell. Note the central position of the nuclei within these cells is clearly demonstrated, and because they are more or less centrally located, oftentimes profiles of the muscle cells will be shown that do not exhibit a nuclear profile. Here we're just getting grazing sections through it, for example, and in this vacuolation is usually there's a little cluster of organelles and glycogen on either pole of these elongated nuclei within the cardiac muscle cell. So this is the reason for this little vacuolation in this cross-sectional profile of a cardiac muscle cell. With very close observation, you can see that there's a little round profiles within these cardiac muscle cells, though it's difficult to demonstrate in this particular preparation because of its thickness. One can, if one looks at the edge of this one, you can see that it's made up of little round type structures. Well, these are the myofibrils that have been cut in cross-section as well, and you can barely resolve them on this particular section. So these are some of the features that can be seen in a cross-sectional profile. Once again, the dark staining nuclei are those of endothelial cells in this very, very vascular tissue. This is a region at increased magnification of the interior of the heart using a routine preparation. So this bright staining orange type of material is the light collagen fibers of the endocardium. With close observation and a little bit of focusing, one can make out that this surface is lined by an endothelium. So the endothelium plus this connective tissue layer from here to here forms the endocardium of the heart. By far the majority of the wall of the heart is made up of the myocardium. So these are endothelial cell nuclei, the cytoplasmic boundaries. One can examine at increased magnification at your own time. Now, these are longitudinal sections of ordinary cardiac muscle cells. As one can see, in this particular region, they're running lengthwise. And within the endocardium, this is where one should look. One should find these large vacuolated cells. A nuclear profile is showing this one. So this is a cross-sectional profiles of a bundle of Purkinje cells once again. The reason they're so light staining and sort of flocculent or fluffy in appearance is that these particular cells not only are large, but they're filled with a considerable amount of sarcoplasm, rich in glycogen, and they only show a few myofibrils that usually have a peripheral location within these particular cells. So these large cells, as indicated by the pointer and cut in cross-section in this particular case, are the Purkinje cells, most often found with greatest abundance within or just beneath the endocardium, which is shown here, and then you can see the endothelial cell nuclei lining this particular structure. Once again, these Purkinje cells are several times the size of ordinary cardiac muscle cells. We're just tracing the endocardium. You can see it's pretty similar all the way along its length, and just to demonstrate once again, another small bundle of Purkinje cells. These conducting are fibers that conduct the impulses. You can see they're located with considerable abundance. Here we're running into some more that are lying in the endocardium, which extends from where the tip of the arrow now indicates to this, even though it's rather oblique or an off-angle type of cut, just to give you an idea of the size of these particular cells and their relative abundance. And here we're getting into some that are cut more obliquely as they're lying at this particular location. So these are the Purkinje cells. Be sure these have been identified, and you can recognize them in the routine type of preparations. I think perhaps the best example, or this small group, as seen in a cross-sectional profile. So these cells are different sections through these very large, flocculent, light-staining cells of the conducting system of the heart, the Purkinje cells. And finally, a comparison illustrating the previous point that was being made. The very large nature of individual Purkinje cell. One is being circumscribed by the arrow. Another one is located here. So compare this cross-sectional diameter, and we know it's through the center as the nucleus is located here, with typical cross-sectional profiles of normal cardiac myocytes or muscle cells, as indicated by the pointer, and one gets an appreciation for the magnitude and the difference in size. So this is a comparison of Purkinje cells and typical myocardial cardiac muscle cells of the myocardium, I should say. Having completed an examination of the heart, begin an examination of the blood vessels, beginning with the arteries. Remember the three layers. The tunica intima of these blood vessels corresponds to the endocardium of the heart. The tunica media is equivalent to the myocardium of the heart, and the tunica adventitia corresponds to the epicardium of the heart, but lacks the mesothelial covering. Shown in the field of view is a section of the aorta. This is an example of the elastic, or one of the conducting arteries. Others in this particular class would be the common iliacs, pulmonary, bronchocephalic, subclavian, and the common carotid arteries. A major feature of this type of artery is the width or diameter of the lumen, which in comparison makes the wall of the vessel appear somewhat thin. And one can view that as we use the scanning objective to trace around the circumference of this particular vessel, in this case the aorta. The tunica media is the dominant feature of the vessel wall, though all layers are present, and it is characterized by 60, perhaps to 70 elastic laminae. These may reach a diameter of 2 or 3 microns in thickness and are spaced about 10 to 20 microns apart. On close observation, we'll see that there's a fibromuscular type of material in between these successive elastic laminae. So this is how it appears at the scanning objective. Now let's proceed and examine this vessel wall at a higher magnification so the details can be studied. This is an example of the aorta as seen at increased magnification. The lumen, of course, is shown here, and the pointer indicates the endothelium and endothelial cell nuclei, or nuclei of endothelial cells lining the luminal surface. The endothelium, together with this underlying connective tissue to about this elastic membrane as shown at the tip of the pointer, constitutes the tunica intima, corresponding to the, as we mentioned before, the endocardium of the heart. So beginning about this point here, where the tip of the arrow indicates, we enter into that huge media, made up of a sort of a muscle wall, an open spiral that courses around, that's hard to visualize here, and separated by elastic laminae. Some of those elastic laminae in this routine preparation are showing here, these thin undulating strands. Remember, the elastic laminae are sheets of elastin that surround the circumference of the vessel lumen, empowering this particular vessel to withstand the surge of blood coming from the heart. And is a protective mechanism, and also allows this vessel, once it has expanded, to go back to its normal dimensions. Most of the nuclei seen here at various angles, most but not all, are smooth muscle cells. The others are fibroblast nuclei that lie between those spaces, or regions between the elastic laminae. Remember, the elastic laminae are probably going to, these sheets, there's probably going to be 50 to 60, maybe even 70, depending on the section. And those are these homogeneous undulating strands shown at the tip of the pointer. Again, simply coursing through the wall of the media, demonstrating these elastic laminae. One is shown undulating here, another one courses here, another one courses here, and so this pattern repeats itself over and over again. Here we're seeing the spiraling nature. Here's of smooth muscle cells between these laminae. Here's one cut lengthwise. These, of course, over here are smooth muscle cells cut crossways, as it forms this loose open spiral around the lumen of the this particular vessel. Now finally we get out to this region here. You can see the large bands of collagen and fibroblasts. So this, we're now entering into a thin adventitia that surrounds this particular vessel. It looks relatively thick here simply because we're at a very high magnification. This is how this vessel wall would look in plastic embedded routine type of preparation. A normal H&E of a paraffin section, the media of the arterial, or this aortic wall, will be like it's comprised mainly of smooth muscle. But remember, one of the reasons for naming this vessel an elastic artery is because of the predominance and abundance of these elastic laminae, which form sheets and circumferentially go around the lumen as a protective type of mechanism. Now examine an aorta that has been stained specifically to demonstrate this particular material, that is the elastic laminae. This particular preparation is a section of the aorta that has been stained to demonstrate the elastic laminae. The intima is shown at the pointer, again consisting at this relatively low mag, you can't see it very well, of an endothelium and an underlying small connective tissue which forms the rest of the tunica intima. So the tunica intima goes right about to where the tip of the pointer is. The intima is relatively thin, consisting of a endothelial layer and then the intimal connective tissue that supports it. The media is a predominant feature, once again, of the wall of the conducting vessel, the aortic wall. And because this particular section has been stained to demonstrate the elastic laminae, other histological features have been lost or much subdued. Nonetheless, one can see the number of elastic laminae, as indicated by the tip of the pointer, and follow this sort of squiggling or undulating course throughout the field. So this is one, there's one here, one here, one here, one here, and so on and so forth. Now the gaps between these elastic laminae, which number between 60 and 70 in some of these major vessels, is smooth muscle and connective tissue, with smooth muscle cells being the predominant feature. We'll go back and look at that after coursing through the vessel wall. So this nature or this structure repeats itself histologically time and time again until finally one goes to the connective tissue at about this level as indicated by the pointer, and this material here is all collagen primarily and forms the adventitia, and there may be a little bit of fat associated with it as well. A small arterial artery at the tip of the pointer is an example of one of the vasa vasorum. These vessels are so large, that is the conducting vessels, such as the aorta, that they need a vascular supply of their own, usually coming from neighboring vessels to supply the wall and the musculature of this particular organ. So this would be a very small artery here. One can see an arteriole extending here, and then perhaps going down in to supply a portion of the media. Vasa vasorum, and you will find these vessels primarily in the adventitia surrounding these large elastic or conducting type arteries. Elements of the vasa vasorum as seen at increased magnification. This is a small artery. It probably has 3 muscle wraps associated with it. You can see an endothelial cell nucleus and just a remnant of the internal elastic lamina. So this vessel extends from here to here as a small, or the smallest of arteries within the adventitia of the aorta. This small vessel extending from it here is at the caliber of an arteriole. It has about maybe 1 or 2 smooth muscle wraps associated with it. So these are elements of the vasa vasorum that are the vascular supply to these very large vessels. Now if we course towards the interior and re-examine this particular structure at increased magnification, several features can be visualized once again. First of all, these are the elastic laminae. Remember, there are maybe 50 to 70 of these. These can be united or interconnected by elastic fibers. Remember, these are sheets of elastin once again. And with very close observation, one can make out the smooth muscle nuclei and the gaps between these elastic laminae. The nucleus is showed in here, one of these smooth muscle cells on this special preparation. Another shown here, another one here. Remember, the cytological detail, or the histological details, have been sacrificed of the remainder of this vessel wall, or the constituents thereof, to demonstrate the elastic laminae because of their importance to these particular vessels functionally. Here's a pretty good example of, at high magnification, of the elastic laminae once again, and then the intervening tissue between the laminae, which consists primarily of smooth muscle cells. There's the nucleus of a smooth muscle cell cut in cross section. So with very careful observation, one can indeed make out the nuclei of the smooth muscle cells as they form a more or less open spiral around the lumen and between the elastic laminae. However, because of this preparation has been stain specific for elastin, the other tissues involved appear as pretty vague. And finally, we get to the lumen. One can make out the endothelial lining, and the tunica intima extends to about this level, so it's relatively thin. Obviously, the dominant feature of the wall of the elastic or the conducting arteries is the elastic laminae. This is why they are called elastic arteries, because of this very dominant feature in the media of the wall of this particular blood vessel. This particular vessel is a muscular or a distributing artery. It forms a very large class of arteries, and except for the elastic arteries and those named vessels named previously, the named arteries of gross anatomy fall into this broad category. Arteries such as the ulnar, radial, popliteal, those types of vessels. One can see by looking at this scanning view, it's quite a bit smaller in caliber as compared to the elastic type of artery. And even at this scanning magnification, one can make out roughly the region of the intima. The intima is going to consist in this vessel, as it did in the elastic or the conducting type of vessel, an endothelium, a little connective tissue layer, a subendothelial layer, and in this particular case, a very well-developed internal elastic membrane, which gives you this scalloped appearance at this low magnification. This structure right here that has that undulating course. But by far the dominant feature that attracts one eye is the tunica media, which extends from the tip of the pointer, as it is indicated now, to this region here, and it is formed almost exclusively of smooth muscle coursing around, spiraling around the lumen in a very tight spiral. The adventitia surrounds the media, and on occasion it can be a sort of a width that's almost identical to the media, but by far the most prominent feature is this tunica media and its smooth muscle component, and this is why they are called muscular arteries, because of this, the smooth muscle in the media. As is true with the naming, if you think about it, for the elastic arteries, so named or designated because of the abundance of elastic laminae within this medial tunica media area. Now usually, though we can't resolve it right here, though it's apparent down at the bottom of the field, there's a boundary, another elastic membrane that achieves prominence. The external elastic laminae that's pretty well developed in these muscular or distributing arteries as well, and it sort of lies at the boundary between the tunica media, which is here, and the tunica adventitia, this connective tissue layer shown here. So now let's go and examine these particular vessels at increased magnification. This is a hematoxin and eosin preparation, another one of the plastic preparations to show what a routine preparation will look like. Then we'll compare this with one that's stained for elastin and look at the very same features. This is a muscular artery seen at increased magnification. Beginning at the luminal surface, one can make out the nuclei of the endothelial cells, as one would anticipate, and beneath the endothelium is a very fine connective tissue layer, this subendothelial layer, and then finally the scalloped membrane, this internal elastic lamina that's so characteristic and well developed in the muscular form of artery. So this is the tunica intima, the endothelium, subendothelial layer, and this internal elastic membrane. From here to where the pointer now stops is all tunica media, and one can see it's almost exclusively smooth muscle spiraling around the lumen of this particular vessel, and on occasion one can see elastic fibers, and depending on how close to the origin from the elastic artery, a few elastic laminae may occur in these vessels when they're cut close to their point of origin. This one seems to be fairly distant from that origin, and a few elastic fibers, little squiggles, can be made out in this tissue even at this point. As one courses through the vessel, this would be the region of the external elastic laminae. More often than not, rather than one thick, robust single membrane, as is true of the internal elastic membrane as shown here, the external one often appears frayed and may consist of 3 or 4 of these elastic laminae sort of unraveling. And this forms the boundary from this point on to the exterior surface, consisting mainly of collagen, though a few smooth muscles with cells with longitudinal orientation can on occasion be found. It's mainly a connective tissue covering, this being the tunica adventitia. Some of these vessels also may have vasovasora associated with them, depending on their size and sort of where they are in where their location is, what they're actually supplying. So this gives you a very good example of one of the muscular or distributing arteries, this particular field. Just a very quick look at the highest magnification, once again running through the layers of a muscular artery. The endothelial cells form a single layer, of course, on the lining the luminal interior. There's a subendothelial layer of a very fine connective tissue just beneath them and supporting this endothelial lining. Then the internal elastic laminae. That makes up the tunica intima. The tunica media forms the bulk of the wall. As one can see, the smooth muscle cells are the predominant and most important feature. A few elastic fibers and occasionally laminae will persist. The external elastic laminae form a boundary between the tunica media here and the tunica adventitia on the exterior surface. And one can see as we go to the exterior surface, made up of coarse collagen fibers and scattered fibroblast nuclei, and other cells, probably some smooth muscle cells scattered, but not in predominance at all. They come and go in this particular layer, are highly scattered. Like if we took another field, some of these aren't present. So there are some present, but they aren't a substantial number. And an occasional basophosaur will be located also in this adventitial layer. So this is the muscular or the distributing type of vessel or artery, seen at high magnification. This is a portion of a section through a muscular artery that's been stained specifically to demonstrate the elastin within this particular vessel. This is a muscular artery, but one that's been cut a little closer to the point of origin from one of the elastic vessels. Beginning at the lumen, the very same layers are demonstrated, of course. An endothelium on a subendothelial layer, that intense internal elastic membrane with its scalloped appearance, much more readily visible with this particular preparation. And then the media, which extends from here to where the tip of the pointer now indicates. There are a few elastic laminae still present, but not as well developed and as robust and as abundant as in the elastic or the conducting artery. The field is going to be primarily of smooth muscle, as is characteristic of a muscular artery. And you can see there are also little elastic fibers are taking over from the laminae as the elastic laminae slowly disappear. The external elastic laminae sort of forms a single here and is at the boundary between the adventitia and the tunica media, which is occupying this area. So this is another muscular artery, but one that has been stained specifically to demonstrate the elastin, and the other morphological features are not obvious in this particular preparation. So it does have an advantage. You get a better idea of the elastic tissue that still remains within many of these muscular or distributing arteries. Having completed an examination of a muscular or distributing type of artery, go then to the wall of an organ and look for small arteries of different sizes and calibers to see what these small arteries look like. They are small arteries because one rule of thumb could be because they're not isolated and they're within the wall of an organ. An excellent place to look, because of its very vascular nature, is in the wall or the adventitia of the gallbladder. The small arteries will show a very prominent media. There's one located here in the center of the field of view, so this is an artery, always characterized, as is the aorta or the elastic, the muscular arteries, all through the arterial system by the dominance of smooth muscle in the media wall. Indeed, some may be modified somewhat, as in the elastic or the conducting type of arteries, but a prominent feature is always the smooth muscle in the media wall that sort of forms a donut, a very prominent ring, all the way through the system, all down to the smallest arteriole. And this should make perfect sense. This is how arterial pressure is maintained, by the contraction and the pressure exerted on the lumen by this media in the smooth muscle wall. Nonetheless, this is a typical small artery. It perhaps has 8 or 10 smooth muscle wraps. Most small arteries, they'll extend maybe from 15 or 20 smooth muscle wraps down to about 3. That's the usual classification, with small arterioles or arterioles having 2 smooth muscle wraps or less. One and then sort of a gap as it opens into an open spiral. So this is a small artery. Associated with it is its companion small veins, because it's here. Let's just go ahead and point it out. and there's another companion vein on the other side. So this one has two small veins accompanying the artery. Now, having located one, then examine it at increased magnification. The same small artery seen at increased magnification. The three tunics are obviously present. The tunica intima, consisting of the endothelial lining, and though it's just barely visible, the internal elastic laminae, and between these two elements, a thin subendothelial supporting layer. The tunica media, which is the dominant feature, and consisting of, let's say, 1, maybe 2, 3, 4, maybe 6 smooth muscle cell layers, and then, of course, the surrounding connective tissue, about the width of the arrow, the adventitia, that anchors this particular vessel into the surrounding tissue of the organ, and which in this case is the gallbladder. This field shows another small artery, almost of equivalent size, though the angle of cut is different than the previous illustration, stained specifically with elastin to demonstrate that indeed the internal elastic membrane remains to be present in this particular vessel. Here's the media making up the smooth muscle wall, as indicated by the pointer. Again, 5 or 6 smooth muscle cell layers thick, and also shown is a rather robust and still being retained the external elastic lamina, and then of course the surrounding adventitia, as illustrated by the arrow. So all of the layers that were observed in the muscular artery are present, though smaller in size, in the smaller arteries within organs, and they will maintain their position until you get down to the very smallest of arteries. And even then, at the level of the arteriole, the internal elastic laminae will maintain its position, though it is indeed smaller. The arrow indicates another example of a small artery within the gallbladder wall, and yet this is a one that is yet a smaller caliber than the previous one that we observed in the gallbladder. Again, the predominant feature that attracts one's attention is this round donut or bagel type of configuration, and the predominance visually of the tunica media made up of smooth muscle. Even at this scanning magnification, one can make out the internal elastic laminae that was demonstrated on the previous illustration. In this particular case, it also has a companion vein associated with it. Now, moving the field slightly and coursing in this direction, one chances upon yet another small artery of a much less caliber, as illustrated by the pointer, an additional small artery of yet lesser caliber, but yet classified as a small artery, and finally, at the tip of the pointer, an arteriole. So we're approaching the end of the arterial tree at this particular point. So going backwards, an arteriole, a very small artery, and another small artery here. So these all will show the predominance of the tunica media, characterized by smooth muscle, and all will show that retained internal elastic laminae. So these are all different calibers of small arteries, all characterized, or the feature that is most prominent is the tunica media and its smooth muscle wall. Although the other layers, the tunica intima with the internal elastic membrane and endothelium, the tunica adventitia, are also present, as you can see, but they are becoming smaller, which would make sense until you finally get to this level and approaching the end of the arterial side of the vascular tree. Just quickly repeating what our previous observation, this is a small muscular artery, internal elastic membrane still present, dominant feature, the media of the smooth muscle, characterized by smooth muscle. Companion vein shown there. A yet smaller tributary, still classified as a small artery, as is shown here. And once again, the dominant feature is that smooth muscle wall of the tunica media, even though one can visualize, even with the H&E preparation, the position of the internal elastic membrane. So it retains its position. A much smaller artery, a tributary perhaps of this particular vessel, making up maybe 2 or 3 smooth muscle wraps, or probably even larger. I'd say maybe even 3 or 4. And then finally, a rather typical arteriole shown at this position here. This is an additional small artery as stained with an elastin stain to demonstrate clearly that this small artery, seen at increased magnification or a fairly high magnification, retains its internal elastic laminae. This particular vessel maybe has 3 or 4 smooth muscle wraps, and even at this particular point, the external elastic laminae is present, and then the surrounding adventitia. I'll move this field slightly so you can see fat cells coming into the field of view to give you a frame of reference for the size of this particular vessel, which is a fairly small artery. An additional very small artery of much lesser caliber than the previous one, maybe 3 smooth muscle wraps, showing you the disappearance of the external elastic laminae, though it may be present on this particular aspect of the vessel. But once again, the vessel itself is characterized by that prominent tunica media and its smooth muscle, and this particular illustration, the elastin, demonstrates the persistence of that internal elastic laminae, even this, for this small of a caliber of vessel on the arterial side. The same vessel as shown here, but if the field has been moved over, there happens to be a smaller or an arteriole located at this particular position. Notice that the media has 2 cell wraps, 2 smooth muscle cell wraps. It looks fairly robust because even in these small arterioles, the media forms the major component of the wall, and it makes it look perhaps more robust than it really is. But note the persistence, again, with this elastin stain of the internal elastic laminae. So this is probably one of the smallest tributaries of a small artery, and that small artery category, so it would be the smallest caliber of the small arteries, and this is an arteriole showing you the persistence of that very prominent smooth muscle wall within the media, as well as the persistence of the internal elastic membrane, as indicated by the pointer. So this is the arterial side of the vascular tree. An excellent example of an arteriole, a classic arteriole, is shown in the center of the field of view and indicated by the arrow. This is a plastic type of section, so some of the details can be made out quite well. This is the arteriole here as seen at high magnification. It is lined by two endothelial cells, the nuclei which are shown here. With very careful observation, one can see the remnant of the internal elastic laminae at this particular position, and its wall is literally made up, or the media is made up of a single smooth muscle cell, the nucleus of which is indicated by the arrow, and the cytoplasm of this cell can be seen circumscribing the vessel wall. This is perhaps the same vessel but cut at a different angle as it's looped through the field, or maybe a neighboring one, showing a single smooth muscle cell, two endothelial cell nuclei or portions thereof, and you can see it's a slightly larger caliber. Both of these, however, would be considered classic arterioles. This is a section of through a portion of the wall of a muscular artery, and what it does have associated with it is sort of a lengthwise and interesting cut through a fairly decent or large-sized arteriole coursing here. So this is an example of one of the vasa vasorum that are supplying the nutritional needs to this particular vessel. That same vasa vasorum seen at increased magnification along the tunica adventitia of a muscular artery. This is the vessel that's cut, and it's a small arteriole. This particular region shows the smooth muscle, which consists of a single muscle layer wrap, as seen in cross-section. The endothelial cells are cut more or less along their longitudinal axis, so you're really not seeing the lumen, and one can make out a little bit of an internal elastic lamina at this position. The vessel then is cut sort of tangentially, so these are smooth muscle cells being wrapped around it, and then finally we get into the lumen. So this is the layer of endothelial cells of this particular arteriole, the elastic laminae still present, and then the smooth muscle wall, again making up the media of this small arteriole. And then the arteriole courses out of the field of view here, and we can see we're again cutting it obliquely, so you're just, or tangentially I should say, just nipping the outer wraps of the media wall. The last two vessels as seen at increased magnification. A small artery making up maybe of 3 muscle wraps, showing the tunica media, and this is the arteriole at this particular location that has 1 smooth muscle wrap associated with it, a smooth muscle cell located here and 1 here. So this gives you a comparison of sort of a terminal small artery at this point and an arteriole located at the tip of the arrow. Having completed an examination of the arterial tree, return to the gallbladder section and examine the adventitia, this particular organ where the vessels are, for capillaries. A fairly decent example of a capillary is shown at the tip of the pointer at high magnification. The vessel wall, the capillary wall, consists of 2 endothelial cells, the nuclei on either side of this particular vessel, and these are lying on a very thin basement membrane that can't be resolved with this particular microscope and staining method. You can see that it has perhaps 1 or maybe 2 erythrocytes within the lumen. So this is the caliber, where of the vessels where most of the exchange is going to take place, mainly being flushed out into the surrounding tissue by the hydrostatic pressure of blood within the lumen. So this is a fairly typical capillary. Move the field around and look at several examples of these small vessels, the capillaries. This is a small vein coursing across the field of view. And if we go up in the particular field, this is that small artery that was examined previously, and the small arteriole that we noted as well. Surrounding and in this particular field, one will see that there's an endothelial cell nucleus located here. This is the extent of that endothelial cytoplasm. There's a little bit of a portion of a erythrocyte there, so this is a capillary as well. Some of them will be smaller than a diameter of 7.5 microns. That is the width of a red blood cell. And when these cells course through these particularly small capillaries, they reduce their size, that is the erythrocyte does, and form little parachute type structures that course through the lumen. Here's another capillary cut more or less obliquely. You can see it's a very thin wall. Here's an endothelial cell nucleus, and you can see it has the width of maybe 2 or 2.5 erythrocytes it's coursing through. This would be a much larger caliber type of a capillary. It's probably 14 or 15 microns in diameter, so it's fairly large and dilated. Another is shown here, and in this particular case we may even be approaching the diameter of a small venule. Having seen capillaries course around within the field and attempt to, or find actually, some small venules. This is one, though it's a little bit disrupted coming into the field of view. Notice that it too has an extraordinarily thin wall consisting mainly of endothelium. There's a little bit of connective tissue being associated with it. One of the characteristic features that will separate it from a capillary is its overall diameter. One can see that this consists of 1, 2, 3, 4, 5, 6, 7, 8, maybe 10 red cells in width, and even though it retains the wall of that very thin nature, this would definitely be called a venule at this particular point because of its overall diameter, in spite of the thinness of its wall. And remember, it is this particular vessel, with its tremendous osmotic pressure inside, that is drawing the fluid back into the lumen to satisfy that osmotic pressure, except perhaps maybe 10%, which is the reason for the lymphatic system. So the high pressure on the arterial side, they're very tiny capillaries where the material, the fluid, the tissue fluid is sort of flushed out and enters the tissue in that connective tissue space, and then the colloidal osmotic pressure within this caliber of vessel has enough force to draw it back in, and except for that 10%. So these are the vessels where that tremendous amount of exchange is taking place. Now eventually, these types of vessels, the venules, will anastomose one with the other and form larger vessels, these small veins. And there's a small vein coursing into the field here. Note again the very thin nature of its wall, mainly an intima made up of endothelial cells and a little sport of connective tissue, perhaps a little bit of an adventitia coming in to give it support at this particular point. And as these larger venules and very small veins increase in caliber and size, they will start picking up a little bit of a media and some smooth muscle, so it's difficult to see on this particular small vein located in the field of view. Examples of capillaries as seen in a plastic section at high magnification. An example of one is shown at the tip of the pointer. the nucleus of the endothelial cell touches the tip of the pointer, and one can make out a small empty lumen. So this is a relatively small capillary, perhaps smaller than the size, the luminal diameter smaller than that of a red cell. These are adjacent fat cells to give some perspective to the size. A more typical capillary is shown here, the endothelial cell nucleus, and then the endothelial cell cytoplasm plus its surrounding basement membrane, making up the overall width of the vessel wall. It should be remembered the number of these capillaries. This part of the vasculature is substantial. This is where exchange takes place, and the total surface area for this exchange has been calculated to be somewhat over 100 square meters in surface area for this exchange to take place in the human body. So they form a substantial population of blood vessels, these very small capillaries, so this exchange can be affected. That same field seen at a lesser magnification, illustrating the capillary at this particular point, a small vein shown here as compared to the wall and overall diameter of a small artery, arteriole, another capillary, a very large capillary perhaps shown here, and then the caliber of a venule showing here. So you can have some idea of comparison with these particular structures. To briefly review and then move the field at relatively high magnification. The smallest portion of a small artery, an arteriole located here, identified because of the smooth muscle, and then capillaries in the background, though these are fairly large capillaries, or have a fairly significant diameter. The appearance of a venule, identified by its diameter and thin wall, a small vein shown here, again characterized by its wide lumen and very thin wall, primarily a tunica intima, its endothelial lining and subendothelial layer supporting it, as well as perhaps a bit of an adventitia coming in to support the wall. As we move the field, we approach and see a small artery of fairly larger caliber. This particular structure located at the arrow would be another venule. Another fairly small vein, though it occupies a considerable portion of the field of view, identified once again by its very thin wall. A fairly decent comparison to show a capillary at the tip of the pointer made up of a single endothelial cell and a little erythrocyte within its lumen. Another capillary shown here, again retaining a single erythrocyte, but in this particular case the vessel wall is made up of two endothelial cells. So capillaries, a venule, a vein, a small vein that is. And here on this particular side one can see a small vein of a very small caliber actually emptying into one of the small veins at this particular point. And of course this vessel consists mainly of an endothelial lining, a subendothelial layer of some delicate connective tissue, and then perhaps an adventitia. Now from this point on, a tunica media will probably come in, and you'll have some, rather than circular, more of an open spiral, so more longitudinally orientated smooth muscle cells forming the media of the wall of the vein. These are the very same vessels, though seen at decreased magnification, showing the small artery at the bottom of the field, its accompanying small vein, venules, capillaries, and then a tributary small vein emptying into this small vein of yet a larger caliber. And then retracing our previous steps on the arterial side, one can make out a small vein located here. On this particular aspect of the wall, it is extraordinarily thin, mainly an endothelial lining supported by an adventitia. And maybe due to the cut or just how veins are, one can make out just a little bit of more tissue coming in the supporting wall on this aspect, and may contain some smooth muscle cells. Here's another small artery, yet larger caliber, and its companion vein located to its side, and that shows similar features to the vein that was just examined, but this one illustrates it a little bit better. The endothelial lining with its supporting adventitial, tunica adventitia, the collagen there. As one courses on this side of the lumen, one can start to begin to make out a layering of smooth muscle cells forming, which is going to form the media on the venous side, though it will never attain the robust, close spiraled nature of the tunica media, that is a smooth muscle within it, on the arterial side. It is present, but much less in abundance, and has more of a longitudinal or an open spiral in its orientation. That is the smooth muscle forming the media on the venous side. Once again, retracing our steps, looking at the caliber of vessels, this is a slightly small artery, an artery of larger caliber, I should say, and with it, as we saw earlier, its companion vein. But in this particular case, just due to the sectioning, one can make out the media coming in, making up a layer of smooth muscle cells as it's cut at the right angle, so these are much more visible. Goes to about this far, and one can see with these open spirals you have gaps in the venous wall. In this particular side, the smooth muscle wall appears, or the media appears to be missing, and you mainly have a supporting collagen adventitia giving support. The intima, of course, is always going to be there with its endothelial lining and a small layer of this subendothelial connective tissue. So this is a fairly decent example of a small vein and the initial appearance of the smooth muscle in the tunica media, even though it's much less well developed when you compare it to its companion artery, in this case the small artery here, which is much more robust and has that very prominent muscular media. This field represents a portion of a wall, as illustrated by the arrow, of a small to medium-sized vein. The lumen is located here, and this particular vessel has been stained with the elastin stain to demonstrate the elastic fibers. Elements of the vessel wall can be made out beginning from the outside in, from where the pointer now indicates to this particular location is the tunica adventitia, consisting of spiraling collagenous or collagen fibers as well as some elastic fibers, as one can visualize here. The sort of gray, darker background is the tunica media, very thin, and a smooth muscle is the primary component of that, and why it is sort of staining this off gray color. And then finally, you have a tunica intima made up of a endothelial layer and a very thin subendothelial type of delicate connective tissue that anchors the endothelium to the media. So this is the lumen here, and you can see the overall depth of the wall compared to the lumen is rather interesting because of the very thin wall nature of this particular vessel wall, as is true of the venous side all the way along. A comparison for the magnitude of size, one can compare to these adjacent fat cells. So this is a small approaching a medium-sized vein as seen with the elastin stain. The vessel within the center of the field of view is a medium-sized vein cut in cross-section. What this particular stain illustrates, using the elastin stain, is the overall proportions of the components of the vessel wall, the tunica intima, tunica media, and tunica adventitia. The tunica intima, of course, will consist of an endothelial lining plus its subendothelial connective tissue, this very thin, fine layer. What's striking is the poor development, perhaps, of the tunica media on the venous side, which in this particular preparation extends from where the tip of the arrow now indicates to about this position. So it's relatively thin and can be visualized by this sort of circular arrangement, or at least running parallel to the luminal surface of these elastic fibers, because this is, after all, an elastin stain. What forms the bulk of the wall of these medium-sized veins is the tunica adventitia. The tunica adventitia extends from where the tip of the pointer now illustrates to this particular position where it abuts the fat. So the venous side is characterized by a very thick, abundant tunica adventitia and consists primarily of collagen, as can be seen here, but it also has scattered elastic fibers within it. So it is not just a collagenous type of fibrous material, but it also has a considerable amount of elastic tissue in it that follows this open spiral along with the collagen. So they have a considerable amount of distensibility to them and can expand considerably and hold and pool blood on the venous side. After all, about 70%, I think it's estimated, of the peripheral blood is on this venous side. So this is a medium-sized vessel as seen with the elastin stain, and one can make out the three tunics of this particular vessel and compare with the proportions of each. The vessel now occupying the center of the field of view and seen with the scanning objective is a fairly large, medium-sized vein, a larger caliber. The details of its wall really can't be seen too well at this low magnification. This animal or individual was obviously perfused. Usually the veins collapse because of the lack of muscle in their wall and the lower pressure. If one compares it to its companion artery, one of those initial vessels that we examined, one can see the very robust internal elastic membrane, the tunica media with its smooth muscle, and then the surrounding tunica adventitia of this muscular artery. This particular vessel is its companion vein, and we'll have to examine it and go through the wall of an area to see some of the histological features, because they're not nearly as marked and well delineated as seen on the arterial side. The medium-sized vein, as seen at increased magnification, showing the details of its wall. The endothelial lining is indicated at the tip of the pointer, the subendothelial layer is quite thin and not readily visualized here. You can see a little bit of a remnant of what appears to be some elastic tissue here as well. So this is roughly the depth of the tunica intima. The tunica media forms a substantial part of this vessel wall. You can see it does have smooth muscle in it in this particular case, but they're not as tightly spiraled and organized as it was true of the arterial side, and so it's a much looser arrangement of muscle tissue, and they form a more open spiral, so they're more longitudinal in their orientation, coursing along the vessel wall. The tunica adventitia, as in the smaller vessels, forms either the majority of the wall in most cases, though this one's a little bit misleading because it does have a well-developed tunica media. And this tunica adventitia will largely consist of collagen fibers. It will have smooth muscle in it that runs sort of longitudinal to the course of the position of the vessel. Here we can see in this particular side the tunica adventitia, of course, is getting fairly thick. So that may have been torn off down here where we examined it earlier. But one can see the smooth muscle in the tunica media, though it's not nearly as well developed and highly organized as on the arterial side. So this is a structure of the portion of the wall of a typical medium-sized vein. This particular field illustrates a portion of a section through one of the large veins, in this particular case the inferior vena cava. Large veins include venous trunks such as the vena cava, renal veins, external iliac veins, splenic veins, portal veins, vessels of that caliber. The remainder of the named veins of gross anatomy are usually classified as medium-sized veins, those veins that we looked at just previously. Looking at this particular portion of the wall of the inferior vena cava, with the low-powered objective and an H&E plastic stain, one can make out the endothelial cells even at this very low magnification. They will be supported by a subendothelial layer of fine connective tissue fibers, as is the rest of the cardiovascular tree. One can see that the media is very poorly represented, poorly developed, consists of some spiraling smooth muscle, and is indicated by the pointer. Now the tunica media, depending on where you are in these large vessels, may be present as indicated here and has smooth muscle within it, or in some places there are gaps, it may be even absent in these large vessels. By far the most substantial component of the large vein, or the wall of these large veins, is the tunica adventitia. It consists of longitudinally orientated or spiraling collagen fibers primarily. It will also have elastic tissue following that similar course, and if one looks closely, we'll find bundles of smooth muscle also with this longitudinal orientation, forming a loose open spiral around the lumen in the adventitia as it spirals around towards the direction of the heart. So they will have a longitudinal, all of these will have a longitudinal orientation in comparison to the luminal profile shown here. So let's examine some of the details of the wall by just passing through it of this large vein, in this case specifically the inferior vena cava. A section through the inferior vena cava, or at least a portion of its wall, as seen at increased magnification using the medium power objective. The endothelial layer and the subendothelial layer forming the intima are located here, this region from here to here, as indicated by the pointer, is the depth of the tunica media. The remainder of the vessel wall, that is of this large vein, is the tunica adventitia. So it forms by far the bulk of the wall, as is true of the entire venous system. The tunica adventitia is the predominant feature. One can see collagen. The elastin tissue is probably hidden in the background, maybe staining a bright color, but we can't really resolve it at this particular field. These structures here are bundles of smooth muscle that are running perpendicular or parallel to the lumen, I should say, and have this open spiral course around the vessel wall. So it's the tunica adventitia that is the preeminent feature of these very large veins, and they do have a muscle component, though it's not as tightly organized, let's say, as in the on the arterial side. As we course around, you can see more and more bundles of these smooth muscle cells. The tunica media is also sort of open. You can see collagen and what have you in between those muscle cells, so that's not surprising, because you will find gaps within them, depending on where you are along this particular this particular class of vessels, where the tunica media may indeed be absent. This is probably a pretty good representation of what's really going on. The intima located here with its subcomponents, the media very poorly represented, and then this rather robust, huge layer forming the tunica adventitia on these particular large veins. Some final observations on this large vein, in this case the inferior vena cava, showing the tunica intima here. The tunica media is virtually absent. There may be one or two scattered smooth muscle cells at this position along its course of the inferior vena cava. The remainder of its wall, as stated previously, is this huge development of the tunica adventitia that consists of collagen, elastic fibers running more or less a helical longitudinal course running sort of parallel to the lumen, as well as isolated bundles of smooth muscle coursing with them. So this is typical of a very large vein, in this case specifically the inferior vena cava.